A very warm welcome to all. Children, in our last session, we have discussed few very important criteria about triangles. In our last session, we have discussed one of the very important theorem that is known as basic proportionality theorem, its converse, and along with that, we have seen few similarity criteria, that is AAA similarity criteria, side angle side similarity criteria and SSS similarity criteria. In our today's session, we are going to discuss few more important things about chapter triangles. So children, let's start today's session. In our today's session, first thing which we are going to discuss about area theorem. This is also known as area ratio theorem of similar triangles. After that, we will take few examples of area theorem. So let's start today's session. Here, let us understand what is the meaning of area ratio theorem. Children, when we have two similar triangles, supposingly we have triangle ABC and triangle PQR and they are similar triangles. So, according to area ratio theorem, the ratio of the area of two similar triangles is equals to the ratio of the square of their corresponding sides. In short, if triangle ABC is similar to triangle PQR. So, according to area theorem, what we have to prove that area of triangle ABC upon area of triangle PQR means their ratio is equals to square of the ratio of their corresponding sides, that is AB upon PQ whole square is equals to BC upon QR whole square is equals to AC upon PR whole square. So, let us start. As I told you, you have to remember theorems in a step. Step number 1, you need to draw the diagram, then you have to write down the given things, then you have to write down what you have to prove, construction, and then you have to start with the proof of the theorem. So, let us start. Here, the given things are only thing, that is both the triangles are similar to each other. Second thing, to prove ratio of the area of the two triangles is equals to square of the ratio of their corresponding sides. Children, here to prove this theorem, we are doing one construction, and what we are doing here, in first triangle, we are drawing AM perpendicular to BC. You all can see this is a perpendicular sign here, and in the next step, we are making PN perpendicular to QR. Alright. So, children, since it is given to us that both the triangles are similar and because of similarity, we can write that the sides of the triangles are in ratio and their angles are also equal. So, this is first thing which we are writing, that since the triangles are similar, so their sides are in proportion, means AB upon PQ will be is equals to BC upon QR is equals to AC upon PR. Remember this first point because we are going to use this point in our next step. So, now let us move to the next step. Here, now again see the diagram. First, how you will calculate area of a triangle. What is the formula for area of a triangle? It is half into base into height. So, if you have to calculate area of triangle ABC, write the formula half into base into height, and for this triangle you can see base is BC and height is AM. So, put down the things in the formula, that is equals to half into base, that is BC, into height is AM. Similarly, for the second triangle, that is PQR, again write the formula half base into height. For this particular triangle, base is QR and height is PN. So, say this is your equation number 1 and this is your equation number 2. Children, in the next step, divide equation 1 by equation 2 and see what you will get here. So, equation 1, to the left side we have area of ABC and here we have area of PQR. Divide them, we have area of ABC upon area of PQR is equals to half of BC into M, that we will put here, half into QR into PN we will put here. Now, children, you can see what are the things you can cancel here. This half and half get cancelled. So, what you left with? We left with area of ABC upon area of PQR is equals to this half and half get cancelled. You left with BC into AM, QR into PN. So, here you got your equation A. Now again see the diagram. You can see we have two small triangle here as well. Now children, in our next task we will show that both the triangles are similar. Let's see how. We will take triangle ABM and we will take triangle PQN. What are the things which you can make common? Here you can see angle M is equals to angle N. Why? Because they both are 90 degree. Angle B is also is equals to angle C. Children, I want reason, think yourself why angle B is equals to angle C. Because the triangles are similar and we know when the triangles are similar, all the corresponding angles are also equal. So, we reach to this step that angle B is equals to angle Q, angle M is equals to angle N. Now, in these two triangles, you are showing that two angles are equal. So, what can you say about the triangles? Then the triangles become similar triangle. Under criteria, remember, under criteria AA similarity criteria. So, you have shown that triangle ABM, this small triangle is similar to triangle PQN. And once the triangle becomes similar, what can you say about the corresponding sides? That they are equal. So, write down carefully their corresponding sides. Corresponding sides are AB upon PQ will be is equals to AM upon PN. See, that's completely up to you. You can write any combination of corresponding sides. So, I am taking AB upon PQ is equals to AM upon PN. Now, see, come back to your equation number 1. Your equation was area of ABC upon area of PQR is equals to BC into AM upon QR into PN. This is your equation number 1. But what we have proved in equation number B? In equation B, we are showing that this AM upon PN is equals to AB upon PQ. It means here in this step, I am going to replace this AM upon PN by AB upon PQ. So, using equation A and B, replace AM by PN by AB by PQ, and here you got your equation number C. Now, the next step is, this is our equation C again, area of ABC upon area of PQR is equals to BC upon QR into AB upon PQ. But children, remember your first equation what you wrote, that the triangles are similar. So, all the corresponding sides are equal. In short, this AB upon PQ is equals to BC upon QR, here this is R, and is equals to AC upon PR. It means both the things are equal. You can reverse or you can rewrite AB by PQ as BC by QR, or you can also write down BC by QR as AB by PQ. So, I will replace this BC by QR by AB by PQ. So, here we are getting twice AB by PQ into AB by PQ, that gives you square of AB by PQ. Children, since again I am using this step, all the three sides are in the same ratio. So, in the next step, if you want, you can write AB by PQ as BC by QR, or you can also write down this is equals to AC by PR. So, children, in this way we have shown that the ratio of the area of two similar triangles is equals to square of the ratio of their corresponding sides. So, now let us practice few examples which are based on area ratio theorem. Let us start. Okay. So, I am reading this question. Question number 1 is, there is a line segment XY which is parallel to the side AC of triangle ABC. You can see the diagram. There is a line segment XY which is parallel to AC of triangle ABC. This is first thing given to you, and it divides the triangle into two parts of equal area. This is something very important. This line XY divide the whole triangle into two parts of equal area, means we can say that area of XBY is equals to area of AXYC, or we can also say that this area of XBY is double or half of ABC, that because it divides them into two equal parts, right. So, we will what we have to find out here? Here we have to find out ratio AX upon AB, this small side AX upon the big side AB of the triangle. This is what we have to find out. So, let us start. You know, whenever we have such questions, we will always start with the given things. So, let us write down the given things. Here, the thing which is given to you is this line xy is parallel to AC, first thing. Second thing which is given to you is that this line xy also divides the whole triangle into two equal parts, that is of equal area. Remember this thing. What we need to find out? You have to find out ratio AX upon AB, that we will write down under the category of to find. Now, let us start. Children, before we will proceed this, recall the properties of parallel lines. It is given here that xy is parallel to AC. So, if xy is parallel to AC, suppose I am marking this angle as angle 1 and say this is angle 2, angle 3 and angle 4, right. So, and this is given that these two lines are parallel. What can you say about angle 1 and angle 2 and angle 3 and angle 4? So, clearly since the lines are parallel, so these two angles, angle 1 is corresponding to angle 2, so they are equal. Similarly, angle 3 and angle 4 are also equal as they are also corresponding angles, right. So, we have written the whole name of the angles here, that angle BXY is equals to angle A, that is your angle 1 and angle 2, and angle BYX is equals to angle C. The same reason they are corresponding angles. Now, if I am selecting the big triangle, triangle ABC and the small triangle XBY, you are showing that this angle 1 is equals to angle 2, angle 3 is equals to angle 4 and angle B is common in both the triangles. So, what can you say about the triangles? We can say that the triangles are similar under criteria AAA, similarity criteria. See, we are equating three things, or if that is completely up to you, if you want you can only equate two angles, but here we have options, we can equate three angles as well. So, now once we have shown that the triangles are similar under criteria AA, now use area theorem. What can you write? What you can write by using area theorem? We know by area theorem, when two triangles are similar, then the ratio of the area of the two similar triangles is equals to square of the ratio of their corresponding sides. So, write down this step. Area of triangle ABC, the bigger one, upon area of triangle XBY is equals to square of the ratio of their corresponding side, that is because of theorem 6.6. Also, the another relation which is given to us is area of triangle ABC is equals to twice of the area of triangle XBY, right. If I shift this area from right side to left side, what we will have? Area of ABC, this we are shifting here, area of XBY is equals to 2 upon 1. So, this is your equation 1, this was your equation number 2. Now, if you see the left hand side of equation 1 and 2, they both are equal. So, when their left sides are equal, you can also equate their right sides, right. So, right side mein what we will have? We will have that AB upon XB whole square is equals to 2 by 1. This is on comparing equation 1 and equation number 2. Now, children, you also know one thing, whenever we remove square from one side, you will get root on the other side. So, we are removing this square from here and we will have root on this side. So, we will have root 2 upon root 1 and we know root 1 is 1 only. So, now we will reach to the step AB upon XB is equals to root 2 by 1. Now, take the reciprocal of this equation. Reciprocal means you are just changing the position of numerator and denominator. So, you will have XB upon AB is equals to 1 upon root 2. Here we reach to this step. Now, children, we are subtracting both the sides of this equation by 1. So, we are writing this as 1 minus XB upon AB is equals to 1 minus 1 upon root 2. Now, take LCM here, LCM will be AB only. Here on the numerator we will have AB minus XB is equals to, again LCM is root 2, on the top we will have root 2 minus 1. Now, see the diagram again. What is this AB minus XB? What you are going to get? AB minus XB will give you A x only. So, you have ax upon ab is equals to root 2 minus 1 upon root 2. That is your answer. This is what you have to find out. Or if you want, you have root 2 in the denominator. Children, you have learned how to rationalize the denominator. So, that is your wish. In the next step, if you want, you can rationalize this root 2. So, your answer will become 2 minus root 2 upon 2. This is first example. Now, let us start the second example. This is no doubt one of the easiest question of this triangle chapter, and the weightage of such question will be 1 or 2 number. You will get such questions in objective type questions, right. So, the question says that there are two triangles and it is given to you that the triangles are similar. There is a sign of similarity between them, and the area of the first triangle is 64 centimeter square and the area of triangle DEF is 121. Another thing which is given to you that EF is 15.4 centimeter. You need to find the length of BC. So, children, there is nothing much. It is given that the triangles are similar. So, area, if you find out the ratio of the area of two similar triangles, that will be is equals to square of the ratio of their corresponding side. That is because of theorem 6.6. So, write down this equation. Now, you have to only opt the thing which is required. I am going to just opt or equate these two things. That is my necessity. So, write down the things which are given to you. Here, ABC area is 64 and DEF area is 121. BC square we need to calculate, that is not given to us. And the last thing, EF is also given, that is 15.4. So, now if you want, you can also rewrite by taking whole square, and when you remove the square, you will have root on this number. I am solving it like this. You have BC upon 15.4, this whole square is equals to 64 by 121. And when you remove this square, right, when you remove the square, you will have root on this number. What is square root of 64? It is 8 and square root of 121 is 11. So, you reach to this step that BC upon 15.4 is equals to 8 by 11. Now, do cross multiplication, and after multiplication you will get the value of BC, that is equals to 11.2 centimeter. So, now let us take third example. In example number third, the diagonals of a trapezium ABCD in which AB is parallel to DC intersect each other at O. You can see they are intersecting at point O. The another thing which is given to you, if AB is twice of CD, this side AB is twice of the side CD, you need to find out the ratio of the area of triangle AOB, this triangle, upon area of triangle COD. These two things we have to check. So, again the things which are given to you, the things are ABCD is a trapezium in which line AB is parallel to DC. Another thing, AB is also twice of CD. So, that is you will write down in given things to find area of AOB upon area of COD. This you need to calculate. Now, let us start the solution, children. Come to the diagram. See, these two lines are parallel, right. If I am giving a number to the angle, say this is angle 1, 2, 3, and say this is, here we have 4, 5 and 6. Okay. So, the lines are parallel. What can you say about angle 1 and angle 4 and angle 2 and angle 5? So, we know when the lines are parallel, then the alternate interior angles are equal, and here angle 1 and angle form alternate interior angles. Similarly, angle 2 will also be equals to angle 5, same reason. So, now write down these two angles. We have written the whole num here, but that is your choice. You can write angle 1 and angle 2, or you can give numbers to the angles as well. So, all the three angles of the first triangle AOB are is equals to the three angles of the second triangle COD. Angle 3 and angle 6 are also equal as they are vertically opposite angles. So, again we can say the triangles are similar under criteria AAA, or you can equate them by using AA similarity criteria. Now, once the triangle becomes similar, after writing similarity, you can write by using theorem 6.6, area of AOB upon area of COD is equals to square of the ratio of their corresponding sides. Write down their corresponding sides. Now you can just pick any of the ratio. I am here equating these two things. So area of AOB upon COD is equals to AB upon CD whole square. Why we are doing this? Because this relation is given to us that AB is twice of CD. So in the next step, AB we will substitute by twice of CD upon CD whole square. Now children, this CD and CD get cancelled. So what we left with? Only 2 upon 1. So here we have 2 by 1 and square of 2 is 4. 1 square is 1 only. So we got the answer that the ratio of the area of triangle AOB upon triangle COD is equals to 4:1. Now let us take one more example. This is the last example, but children, there are so many good examples given in your book, so you can practice from there as well. But this is one of the very important question from your exercise. This question says you have to prove that area of an equilateral triangle which described on one side of the square is equals to the half of the area of the again equilateral triangle which is described on the diagonal of the square. So we are given with a square ABCD and there are two equilateral triangles, triangle ABE which is on one side of the square and there is another equilateral triangle BDF which is on the diagonal of the square, right. So we have to show that area of this triangle is equals to half of the area of the triangle which is formed on the diagonal of the square. So let's start. We have ABCD is a square. Let us assume that one side of the square is A unit and you know all the sides of square are equal. So if one side is A, all the sides are also equals to A. What we have to prove? We have to prove that area of ABE, this equilateral triangle, upon area of this equilateral triangle BDF is equals to 1 by 2. This is what we have to prove. Now, proof, let's start. Children, as you can see, the side of a square is A and one of the equilateral triangle is formed on the side. So it means the side of triangle ABE is equals to A units only and the second equilateral triangle BDF is formed on the diagonal. How to calculate diagonal of a square? If this is A, this side is also A, then what will be the value of this diagonal? We can use Pythagoras theorem here to find out diagonal. So this value will be root 2A. Okay. So children, steps are very easy. Simply you have to show that both the triangles are similar and once the triangle becomes similar, just use the theorem 6.6. But how the triangle becomes similar? Both the triangles are equilateral triangle, first thing, and all the angles of equilateral triangles are of 60 degree. We know this fact, right? So if all the angles of first triangle are is equals to all the angles of second triangle, it means the triangle becomes similar under criteria AAA, similarity criteria. You can even write this directly since the triangles are equilateral triangle and all the angles are of 60 degree, that is why they are similar. So once the triangle becomes similar, use theorem now 6.6. So what we can write? Area of triangle ABE upon area of triangle BDF, that is equals to square of their corresponding side, that is AB upon DB. Now as discussed, AB, that is the side of first equilateral triangle, is equals to side of the square, that is A, upon DB is the side of the second equilateral triangle, that is equals to root 2A. So just put the values here and you can see here A and A get cancelled and we left with 1 upon root 2 whole square. Now 1 square is 1 only and root 2 square is 2. So we get area of ABE upon DBF is equals to 1 by 2. Hence we have shown that an equilateral triangle which is formed on one side of a square, that area of that triangle will be is equals to half of the area of equilateral triangle which is formed on the diagonal of the square. So children, in this session we have covered one of the very important theorem of chapter triangles, that is area ratio theorem. Let us quickly summarize what this theorem says. The theorem says when two triangles are similar, then the ratio of the area of two similar triangle is equals to square of the ratio of their corresponding sides. Along with this, we practice few examples, but yes, there are so many good examples. So children, keep doing practice, stay connected. Thank you so much.